Yes, thank you for the introduction. So I'm going to report on my experience with maintaining the Debian Charliecloud package for the last 7.5 years. Probably there is no need to introduce Charliecloud to this audience. Instead, I will use the time and say a few words about Debian and introduce you to its tool chain and describe how this toolchain was helpful for me for package maintenance. So yeah, I will start with a few words on Debian. Then I will give some background about Debian, about Charliecloud in Debian. And then the most of the talk, I will present quality assurance tools used by Debian, which have been very useful, at least from my point of view. And then I will conclude by describing that this is not only a one-way information exchange, but actually a bidirectional information flow. So Debian is a Linux distribution which is developed by more than 1,000 volunteers spread around the world. It puts very strong focus on free software, and it's known for its stability and that upgrades from one major version to the next one run smoothly. New major versions are typically released every 2 years, and then starting from the release, 3 years of support are done by the Debian security team. So this includes most of the packages, um, and it includes all release architectures. So after 3 years, the long-term support team takes over until approximately 5 years after the release. So, and there, this comes along with a reduction in the supported of architectures. But in terms of packages, it's very similar. And then after 5 years, if you want to still have support, then you can buy support. So this phase is called extended long-term support. And there's a company offering up to 10 years. So in total, if you want, you can have up to 10 years of support. Debian is the base for many derivative distributions, and it's probably one of the distributions with most supported packages. So in total, there are more than 30,000 source packages, and from those source packages, more than 120,000 binary packages are built. So the numbers are applied to the present bookworm release. Debian Archive is divided in different suites, and they correspond to different levels of code maturity. So it's stable testing, unstable. Unstable is also called SID, testing, stable, and old stable. Most of the development takes place in the unstable suite. Any Debian developer can upload new package versions at any time to this suite. If new packages are uploaded, then they will end up in the FTP master queue for review. So the FTP masters will check that license-wise and also packaging-wise, it's okay for inclusion in Debian. So the testing suite is the staging area for the next stable release. Packages automatically migrate within a few days from unstable to testing unless automated package tests fail, or if some persons file release critical bugs. And yeah, this will prevent migration. This automatic migration is switched off during the freeze phase shortly before a release. And if if release critical bugs remain unfixed for too long, then they are auto removed. And then there are the stable and old stable release. These are fully controlled by the release team. And its contents is usually taken from from testing. So what is in testing will become the next stable release after a freeze phase, and this happens approximately every 2 years. So suites divide the archive in terms of code maturity. There are also different areas, and they divide the archive in terms of code freedom. So everything in main is free software. Then there is contrib. This contains free software, but which has non-free dependencies. And then if neither the software itself nor its dependencies are free, then it ends up in non-free. And then a few years ago, there was so non-free firmware has been split off in a separate area because these days it's quite hard to run hardware without proprietary firmware. So this way, people can use this firmware without enabling the non-free area. So only the main part is part of Debian, but nevertheless, using all other areas is supported. Debian binary packages are shipped in deb format. So this is nothing but an AR archive containing 3 files. One file is nothing but the Debian format version, and then there are 2 archives, 2 tarballs. The control tarball contains metadata and scripts which are run before installation or after installation or before or after removal. And the data tarball contains then the actual files to be installed. There is no need to fiddle with R to install Debian packages. Luckily, there are convenient higher level tools like DPKG, which is a medium level tool, or even higher level like APT or apt-get or similar. So the task of Debian package maintainers is, among others, to provide a recipe to build Debian binary packages from source. They have to address bugs if they are reported, and where applicable, they should be forwarded to the corresponding upstream project. Then, of course, it's a task of the package maintainer to regularly update the package whenever a new upstream release comes out. And sometimes addressing bugs or fixing bugs requires backporting upstream fixes in case there is a misalignment between the upstream releases and the Debian release cycle. So if a package is in Debian stable, you can't upload a new release just to fix a bug. So if there is really, let's say, a security issue, then you have to backport the fix for the security issue to stable instead of upgrading to new upstream release. And then also a very important task of a package maintainer is to keep the package compliant with various requirements. These include the Debian Free Software Guidelines. It includes legal requirements, so to comply with licenses and to make sure that all the copyright notices are properly documented, and also to comply with the Debian policy. There is no canonical toolchain or workflow to maintain Debian packages, but there are recommendations. I will not describe the details here. Instead, I will show you a few guidelines which you have to keep in mind. So they should be fulfilled when building of at least official Debian packages. So Debian builds everything from scratch. For example, if upstream delivers a configure script, it regenerates everything by running autoreconf. Um, the build process must not download any software from the internet, and we try to avoid vendor software wherever this is possible. And builds are done in a fresh, clean, and minimal environment. These days, this typically means they run in separate kernel namespaces. In the old days, they were typically run in change roots. So this ensures that all the build dependencies are complete. It ensures that the history of the build host does not impact the build. And network namespaces are nice to enforce the rule that no software is downloaded from the internet. Charliecloud has been initially packaged by Lucas Nussbaum at the end of 2017 and beginning of 2018. Since then, it's team maintained under the umbrella of the Debian HPC team. I joined this effort in January 2018, and since then, I'm continuously contributing. So far, Charliecloud has been in 3 stable Debian releases, and unless something strange happens, it should also be included in the next release, which will be called Trixie, which is due probably sometime this year. So Charliecloud is distributed over 6 binary packages in Debian, so quite granular uh, yeah, package architecture. So inside, or the Charliecloud package is just a meta package which pulls in the build and runtime tools. There is a Charliecloud common package. It contains common files which are used for all packages. Then there is a separate package containing only the build tools and their man pages. Then a corresponding package containing the runtime tools and their man pages. And then there is a package containing the documentation and the test suite. So a big part of work of Debian's work is to make sure that all the different packages work together, both at build time and at runtime. So integration work is really significant here. And this can only be done if you have powerful quality assurance tools and if they are automated as far as possible. The different tools, they differ in terms of what they cover and when they are run, and also on which architecture they are run. In the following, I will present some of them, which I regularly use. Lintian is a Debian package linter, and it checks for typical packaging errors or policy violations. It checks for deprecations, and there are also various other common errors which it checks for, like typos. And here I have four examples of Charliecloud issues where Lintian spotted them. So in the early times of Charliecloud, it complained that there were Charliecloud executables without man pages, and actually this inspired me to look into providing man pages. So some time ago, it complained about erroneously executable files. It found that some time ago, um, one of the man pages was assigned to the wrong man page section, and it also found typos, which I then reported in these issues or pull requests here. Then there is PioParts. It's a tool which tests the installation, upgrade, and purging of packages. So this is again done in a temporary minimal environment. So again, these days it's typically namespaces. And it compares the state of this environment before the installation and after the removal. And if there are differences, then it reports them such that we make sure that there are no remnants left. Then there is a tool called auto package test. It basically runs a test suite to ensure that the package is working correctly. It has to be set up by the package maintainers, but of course, they can recycle tests used or developed by upstream. You can run them on your local machine. You can run, or they are run as part of a CI pipeline after you push the code to a repository, which is prior to upload to the Debian archive. And then after the upload, they are also run, and this post-upload test, they are run on all release architectures. Usually before you don't have many architectures available. So in most of the time, you just test on one or two architectures, and then the full architecture coverage is only after the upload. It also checks for regression in case dependencies are bumped to new versions. And if regressions are spotted, then the migration of these new versions to testing is blocked. For Charliecloud, I basically set up an auto package test which runs the 90 seconds to Charliecloud tutorial, which includes all the essential parts. So here are a few issues which were produced well, thanks to this auto package test. So there was a syntax warning with by then new Python version. So it was 3.12, which is not new anymore. And then while preparing these auto package tests, a few other things were spotted. For example, Charliecloud printed output to standard error, although there were no errors, and the auto package tests usually consider it an error if anything is printed to standard error. I discussed this with the Charliecloud developers, and then they came up with the proposal to introduce a quiet option, which changes this behavior. If I remember correctly, then only errors and warnings are actually printed to standard error. The preparations also widened the tested architectures, and then I found out that on architectures which didn't support seccomp support, or which hadn't seccomp support in Charliecloud, chimage failed silently with a strange, confusing error message. So this is fixed. And so S390X was the only unsupported seccomp architecture for seccomp support where the shipped Charliecloud examples run. So I added it to cover also that architecture. Then we have BLHC. It's a build log hardening check. It scans the build logs for missing hardening flags, and so a few years ago it found two missing flags in one of the make files for the examples, which is fixed. Then we have a repro test. It checks whether the package is built reproducibly. That means all the build artifacts are bit by bit reproducible by third parties. So this ensures that actually a given binary package was built from a given source package, or whether somebody has tampered with the supply chain. So repro test found one issue so far in Charliecloud some time ago. It's also fixed. So there was a bets file contents which depended on the locally test setting. So for different localies, the file contents was different, and therefore it wasn't reproducible. So this is also fixed. This is a screenshot of the pipeline of the Debian GitLab instance. So see, you have three stages. First, it checks whether the sources can be extracted, then builds are run on two different architectures, and also it's checked whether the sources can be built. Then various tests are run on the built artifacts. Most of them I presented here. Another thing is Debian regularly rebuilds its archives or parts thereof to look for issues which either were introduced and not spotted yet, or will be introduced by envisaged future changes. Uh, this regularly finds many issues, especially after profound changes like switching to a new compiler version. And so those maintainers who take care of those essential packages, so which are important for the tool chain, they usually do this well in advance and then file bugs in time with a lower severity level or with a normal severity level, and then they raise the severity level over time, and then at some point it will become release critical, and if it remains unfixed, then the package is auto removed. So this allows the package maintainers to provide an early heads up to the upstream projects, and ideally this leads then to new upstream releases, including fixes, such that the only remaining task to fix those bugs for the maintainer is to package this new upstream release. So far, I mainly reported on information which flew from Debian towards the Charliecloud maintainer, but also the opposite happens. So information flow also happens from the developers to the maintainers, and this actually happens quite regularly. I've got a few examples here. For example, in the beginning, shortly after packaging Charliecloud, there was a troublesome Debian link in the upstream repository, which caused a conflict with the Debian directory in the Debian repository. And so after some discussion, it was just removed. And then there was a discussion whether these auto tools maintainer mode should be switched off, whether this uh, whether this causes any trouble for maintainers. There was a discussion whether the documentation should be changed. There was also discussion whether the upstream Debian packaging should be removed from the repository, and it actually has been done now. So now if you want to build your own packages, Debian packages, you should just take the packaging code from the Debian repository. We had a discussion on how long the storage directory or different storage directory versions should be supported. And we also did some path adjustments to get rid of a Debian specific patch. So this brings me to the summary. So I really think that in a healthy environment, upstream projects and distribution can cross-fertilize each other. So upstream projects and distributions have different focuses, they have different tool sets. And in most cases, it also means that more peoples are involved and this broadens the coverage. And usually this leads to better end products. Last but not least, being involved in a nice community is also a lot of fun. And to summarize my talk in one sentence, I would say that Charliecloud is really an exemplary upstream project. It's very nice to work with them and to package their software. Thank you.